Yeah.
Also, which polynomial?
So I have, here, I'll just show you, I'll show you the way I have it broken down, and then I will tell you what we're doing. So for the open note quiz tomorrow, I wrote, this is more for me, I wrote just an outline of every single question that will be on it. So for example, questions 1 through 4 will ask you to find the degree of the monomial, and then I have some examples here. No, these are just my notes, so that I use these when I write out your notes in class, but this is just the outline of what's on it. Questions 5 through 7 will ask you to classify a polynomial by the degree and the number of terms, and these are just examples of the questions. It doesn't have any of the notes on it now. And then I go through number 8, that's what number 8 will look like, something like that. Number 9, that's what number 9 will look like, something like that. Number 10, that's what number 10 will look like. And then all the way from 11 down to 20, okay? So that's the general outline that I use when I write your notes in class. So first period, I started with, this is what I wrote in first period. I started with questions 1 through 4. And then for the examples that I had, we actually solved them. We wrote notes for them. Those are the easy ones. And then 5 through 7, classifying the polynomials. We solved them, well, not solving, but we named them, wrote notes for how we got their names. That's how we do it when we do our review, right? But it takes a long time. It's like teaching 3 whole lessons, which each lesson is 2 days. So it's like 6 days of work in one class period. So I ended up very much rushing at the very end. And if I did that in first period, I probably will do that in the other classes too. So that's why I'm gonna go ahead and for you guys, and on this video, skip to number 14, because we're gonna not have time to go through these in detail in regular class. So let's go ahead and work them out in detail now. So I know this will feel a little bit out of order, but keep in mind that all the questions are numbered. So if you want, you can leave a few pages of space in your notebook, or just write it where you want to write it and then use it tomorrow. Okay? So for number 14, can somebody open the door for us? Did I hit record?
Yeah.
Okay. Oh my gosh, let her in. For number 14, it wants us to multiply a binomial times a trinomial. And we can simply use the table method. There is also the distributive method, but we're going to stick with the table because I found that you guys felt more comfortable with the table method. If for some reason you love the distributive method and that's what you want to use, fine with that. But I like this table because it keeps everything so organized. So step 1 is the table. Okay. Make a table with both polynomials. Step 2 will be multiply to fill in empty boxes. And if any of my explanations make you go, what do you mean by that? Then just say, what do you mean by that? And I will explain it better. Multiply to fill in empty boxes. So let's do that before we write out step 3, okay? So we're going to multiply using our rules, okay? To get this empty box, we multiply 3x times x squared. What will that give us? What will that give us? 3x times x squared will give us. Very good. 3x to the third. Remember, x times x squared is x times x times x. That's x cubed. Another way to think of it is adding the exponents because we're multiplying the same basis. Okay, this empty box requires us to multiply the 3x times the 2x. What's that?
6x.
Nope.
6x squared.
Very good. 6x squared. I think sometimes you guys get confused when the terms are like. Your brain automatically tries to follow the rules of combining like terms, and then you leave the term the same. But that is only for addition and subtraction. Multiplication has a different rule. It's add the exponents. Follow same basis rule, add exponents. That's like a little extra. Then we have this empty box, so we have 3x times -1, which is good, -3x. And then we'll do this row, 4 times x squared. Good, 4x squared. 4 times 2x.
8x squared. Oh, 8x.
Good, 8x. And then 4 times -1. -4. So look how many terms we have. 1, 2, 3, 4, 5, 6. Will we end up with 6 terms in our answer? Really? No. Notice anything that some of these have in common? Like terms. Like terms. So the last step is combine like terms and write in standard form. So if we're writing it in standard form, that means we need to start with our highest degree, which is what? Nope. Nope. I think you guys are looking for the highest coefficient, which is not the degree.
Wait, no.
What's the highest degree? 3x cubed, because the exponent 3 is the highest degree that we have there, right? So we're going to start by writing 3x cubed. It cannot be combined with anything else, so that will be 3x cubed. Then, what's the next highest degree? Yep, the x squared terms. Can we combine anything?
Yeah.
Yep, the 4x squared and 6x squared. What do we get?
10x squared.
Yeah, so we have plus 10x squared. Next,
8x.
yep, then we have our x terms, which can also be combined. Combined, what do we get? Positive 5x. Positive 5x. Remember, identifying your signs is so important because these terms are being added or subtracted, right? That's how terms are kept separate. So whatever the sign the number is, that's either the addition or subtraction sign. So if it's positive 5, you actually have to write positive 5. And then our last term will be just a constant, which is negative 4. Are there any questions about this specific problem that I can clarify for you? Because I want you guys to be able to get this question. Number 14 is going to look very close to this. It won't be the same numbers, but it will be a binomial times a trinomial you will have to set up a table and follow all these steps to get it correct. So, do you 100% feel like you are ready to answer that question correctly using these notes? If not, ask me for clarification. Say, I don't get it. Help me with this part. I don't understand how you got this. Why did you do it this way? Just ask me questions, okay? Number 15 is going to ask you to find the area of the shaded region. It's going to give you a picture of two squares. One big square and then a little square inside of it. Now, if it's asking to find the area of the shaded region, are they asking for the area of the entire big square? Are they asking for the area of the little square inside?
No. Oh, no.
No. They're asking for the area of the big square without the area of the small square. To take out the area of the small square, we simply need to take it away by subtracting it, right? So in order to solve this final problem, which is a simple subtraction problem, we first need to solve this area and this area. So, area of big square equals what? Now, I don't want the answer, I want you to set it up for me. How do I get the area of the big square? Multiply what? Yeah, what are they? X plus 5 times what? Good, x plus 5. Now, there are two ways to multiply this. You can either use the table or you can distribute. There's also the FOIL method, which I'm sure my book hasn't taught you that yet, but we'll talk about that another time. So would you like to do a table or distribute? Table? Alright, I'll do my table over here. Just a regular old tic-tac-toe will be quite enough. Shade in the top left. And then we simply put our x and our 5 here, our x and our 5 here, and we start to multiply to fill in the empty boxes. X times x is? See, you did it again. You looked at it, you're like, oh, they're like terms, so it stays the same. That's only for addition and subtraction. But this is multiplication. X times x. What?
I don't think I like this anymore.
Oh, you never did.
I did not.
You did? Aw. Okay, so follow the same basis rule. Add the exponents. If you don't see an exponent, the exponent is 1. So x to the 1 times x to the 1 is x to the 2, or x squared. X times 5,
X to
5x. 5 times x, and 5 times 5, now we're simply using the same steps as the previous question. So we don't need to write them again because you'll still have your notes on them. But we're going to combine like terms and write in standard form. So the area of big square equals, start with your highest degree, x squared. Combine your like terms. Next highest degree is your x terms, so 5x plus 5x is 10x, so plus 10x. And then our constant, positive 25, so I put plus 25. That's the area of the big square. And And then we can wake up from the nightmare that is algebra. Then we need to find the area of the little square, or the area of the small square. Area of small square. Yep, would just be x times x, which is x squared. And now we need to do our little subtraction problem. We have x squared plus 10x plus 25. Now we need to subtract x squared. Where should I put that?
In the.
Where can I line that up if I'm setting it up vertically?
Oh,
In the front? So subtract x squared. I'm gonna put it where it has a like term, right? And we're just gonna subtract x squared minus x squared is what? Nothing. So what am I left with? No, I'm not left with nothing. 0 plus 10x plus 25, which is 10x plus 25. Where did I get what? Oh, down here. If you were to write it horizontally, okay, so I'm gonna vertical method. That's the vertical method. If you were to do the horizontal method, if you think it will be helpful to you, I would. But if you just want to choose one method and only write that one down, that's fine. The horizontal method would be to just write everything horizontally, x squared plus 10x plus 25, and then just simply write minus x squared. Then you would simply circle the terms that can be combined with their signs, seeing that they would cancel out, and you would be left with 10x plus 25. Are these notes clear or are they weird? All right, so that is number 15. Number 16 is asking you to find the quotient. I solved it quickly in first period, but we're going to write the steps. Step 1 would be divide coefficients. Step 2, divide variables. Use same base rule, which is subtract exponents. Do you guys want me to write anything else for clarification there? I'll just write 90 over 18 equals 5. X to the fifth over x to the third equals x to the fifth minus third equals x squared. 17, sorry, I just stopped writing altogether. 24x cubed minus 12x squared plus 30x divided by 3x equals, how do I rewrite this? How do I rewrite this so that I can solve it?
Circle, curve, order. Divide every single one by.
No. We divide each term by 3x. So we have 24x cubed divided by 3x minus 12x squared divided by 3x plus 30x divided by 3x. So rewrite so that you can divide each term by divisor. Then, what am I? So, 24x cubed divided by 3x equals 24 over 3. And you know what? This is just going to be so complicated if I. I'll just do this now. I'm just gonna do that. So we've got 24, and then we're gonna do divide coefficients first. Coefficients first, then divide. Yeah, these are the steps. It's the same steps as up here, divide coefficients, then divide variables. Because this is like the simple example, because it's only a monomial divided by a monomial. This one ends up being monomial divided by monomial. You just have to do 3 of them. So it's just like a reminder. This is a reminder of the rules. Divide coefficients first, then divide variables. So 24 divided by 3 is 8. X cubed divided by x. X squared. Never be afraid to write a little one exponent there. I'm not, just because I want this to stay exactly like what the example says, when I post it in Canvas. So x cubed over x to the first is x squared. Then we have minus 12 over 3, or x squared over x.
Oh, it's just x.
Just x, very good. Plus 30 over 3, 10. X over x.
There's no x.
There's nothing. Technically, there's an invisible one. So I'm going to write a special. Remember that anything divided by itself will cancel out. So that last term has x over x, which cancels out and disappears. probably it cancels out to 1, but 10 times 1 is 10. I have to write that. My OCD. Technically cancels out to 1, which is invisible. That makes sense? Are you getting these down, Vicky? Is that the truth, or are you just nodding? Are you getting all of them down? Everything in there? So, are you supposed to be getting some of it down or all of it? Huh? All of it. And you know that, so get all of it. Okay.
So this is
So do number 18. Find GCF of y cubed, y in the fourth, and y in the sixth. What is it? What is it? Why? Huh? It's a period. I'll go with this. Find the GCF of y to the third, y cubed, y to the fourth, and y to the sixth. It is y to the third. That's all that number 18 is going to ask you. They'll give you probably a different variable, maybe different exponents, but what's the rule?
the lowest one is always
The lowest exponent is the GCF. Now, it doesn't mean that GCF is 3. It means that the GCF is y to the third. And I'll show it now. Y to the third, y to the fourth, and y to the sixth. It would be y times y times y, y times y times y times y, and this would be y times y times y times y times y times y. The number of y's that they all have common is y times y, that's y, or y. That's the end of the sentence. I need a different way to show the end of the sentence. Two more. We good? Okay, so number 19. 19 and 20 are probably the hardest ones. Yeah?
Can you go back up a little bit?
Yeah. Number 19 and 20 are probably the hardest ones, so pay close attention, okay? Number 19 is going to say factor out
I think both can be on the test.
everything I'm writing is going to be on the test. factor out the negative sign with the GCF. Can I move up, Emily? Can I move up?
Yeah.
Okay. Factor out the negative sign with the GCF. So it's going to give you a polynomial that starts with a negative term. So step one would simply be identify GCF and make it negative. Is it okay if I just write neg? Identify the GCF and make it negative. So the GCF would be, what would the GCF of 12, 18, and 27 be? Yeah, so it would be 3. And then we would have x cubed, x squared, and x. So the GCF of the variables would be x, right? The lowest exponent, which is x to the first. So it's just x. And then we're going to make it negative. And when I say make it negative, we are actually factoring out the negative, and that's gonna cause all of these to change their sign when we do our next step, which is divide polynomial by the GCF. So we're going to take negative 12x cubed plus 18x squared minus 27x, and we're going to divide each term, by GCF. Just my extra note there. So divided by negative 3x divided by negative 3x. What do we get? Good. 4x squared. Negative 6x, good. Positive or plus 9, and then x over x cancels out. Remember that a lot of the notes that are helpful for a question are from a previous question, because this quiz goes in order of how you learned it. Each time you learned a new concept, it was built off of something else. Now, this is not your answer. What are we missing here? The GCF. So we have to write this with our GCF as one of the factors. This is the GCF. GCF times the rest. Remember? What?
Can I just know?
Yeah. Write answer as GCF times the rest. And then the rest is what you get after dividing. Does that make sense? So this is the
What's below that?
Huh?
What's below that?
There's nothing. All right, I got one more. I probably will need an extra minute or so. I suggest you guys stay. Okay, Zach can go. But I think you guys should stay. I'll go through it kind of quickly because I did go through it yesterday with the homework. It is one of those, I'm gonna have it on campus, okay? I only have a few minutes. I can put it back up if you wanna stay an extra minute during lunch. But I just don't wanna keep everybody. Okay, so the last question, number 20, is going to say factor out GCF to find missing dimensions. Dimensions, that must mean there's a shape coming up. So we have a long rectangle that's split into two pieces. One of the pieces has an area of 6xy squared, and the other has an area of 15x cubed y to the fourth. Then we have a missing width of the whole rectangle, and a missing length of the little rectangle, and a missing length of the bigger rectangle. Now keep in mind that this missing width is the width of the entire rectangle, but it's also the width of the little rectangle, and it's also the width of the bigger rectangle. They all share the same width, right? Okay, so to factor it out, I'm going to have to take the entire area, which would be this and this. What does and mean? Add, very good. So the entire area is 6xy squared plus 15x cubed y to the fourth. And the instructions say, factor out the GCF to find the missing dimensions. Well, guess what? The GCF is what these have in common. What do these rectangles have in common? The width. So the GCF is the width of each rectangle, which we just need to find this one. It's the same for this. Does that make sense? We need to find the GCF of these, the greatest common factor. That means that it's the same for this and this. Well, what part of the rectangle is the same for this and this? The width. So when we factor out the GCF, Zach, you can go, bud. When we factor out the GCF, that will give us one of our answers. So what is the GCF? 6 and 15? 3. GCF of x and x cubed?
X to the second. No, X.
Just x. Very good. Remember, GCF is the lowest exponent, okay? Now, y squared and y the fourth? Y squared, very good. So that's our GCF. That's the width. That's our first missing thing. GCF is this, which is the width. Now we need the length of this and the length of this. Well, when we factor it out, so let's factor out the GCF, when we factor it out, we're going to take our binomial here and do what we do whenever we factor out a GCF. We're going to divide each of them by the GCF. That is going to give us the dimensions for the length of the smaller one and the length of the bigger one, because we're going to factor it out of this and get the other factor of this area. Okay, so when we do that, we get 2, x over x,
The X to 2.
gone. X over x, gone. Y squared over y squared, gone. So it's just 2. Okay, now we have 15 divided by 3, 5. X cubed over x, x squared, y to the fourth over y to the second, y squared. So this is the length of small rectangle, and this is the length of large rectangle. So all this is requiring you to do is do the exact same thing that we did in other GCF problems You use this as a polynomial, a binomial. You identify the DCF, factor it out, and you'll be left with your answers for the missing numbers. Does that make sense? Okay, I'll have all of my stuff up on Canvas as well.